Hello everybody. In this video we are going to talk about our bottom-up parsing, which is also known as your LR parsing. So bottom-up parsing, as we had already discussed in a previous video, can either be your operator precedence parsing or your LR parsing. And LR here stands for, the L stands for left to right scanning of the input, and R because it produces the rightmost derivation in reverse. So that's what LR stands for. Now there are different types of LR parsers. Okay, so LR parsers also, we have seen that these are also known as your shift reduce parsing. So there are four types of LR parsers. So LR0, SLR or simple LR, LALR and CLR. And within bracket, what you can see, you can understand this notation as LR does not have any look ahead symbol. It does not use any look ahead, whereas SLR, LALR and canonical LR or CLR uses one look ahead symbol. So we will look at each of the different parsing process of these four types of LR parsers. Now here you can see the four LR parsers. The one with which is the least powerful is LR0. This is the least powerful of all your parsers, LR parsers, and CLR, this is the most powerful. And here you see that the algorithm for constructing or performing the parsing for all these four is the same. So you have the same algorithm which is used. So same parsing algorithm for all. Same parsing algorithm is used. So what is different? The difference is in the construction of the parsing table. So these are also, all four of these are your table-based parsers. Just like we saw our LL1 parser, which was a table-based parser, we look up the parsing table. So here also you have the parsing table, which is different for all four of these. Construction is different for all four, but the parsing algorithm is the same. So you have your just like you have in LR top-down parsers, you have the input buffer. The input is kept here. Then you have a stack. Okay, you have a stack, and you have a parsing table. You have a parsing table. So the parsing table will tell you how to look at the stack and how to look at the input, and then make a decision whether to shift or to reduce. So the parsing algorithm will look at what is the element at the top of the stack, what is the element at the beginning of the input symbol, and then it will look up the entry in the parsing table and then make a decision, decide whether to shift or to reduce. So this is about your the parsing algorithm. We'll see the parsing algorithm in details later. But coming back to this, now as I said, the parsing table construction for all four of these are different. And to construct the parsing table, we need something called items. We need something called items. Okay, so we have what is known as LR0 items and LR1 items. So for LR0 and SLR, we use LR items. So for LR0 and SLR, we use LR0 items. Whereas for your LALR and for canonical LR, we use LR1 items. So let's see what an item is. But before that, let me tell you that given a grammar, suppose you're given a grammar and you have to construct, do a parsing on it, okay, you have to perform an augmentation of the grammar. That means, say I have a grammar like this, parenthesis followed by S followed by epsilon. Okay, so what we have to do is we have to augment the grammar. How? By adding a new start symbol, say S dash, and we add this production, S. So now my grammar becomes S dash derives S, and S derives whatever it was earlier. Whatever it was earlier. So this is our augmented grammar. So we have to perform an augmentation. So let us see how we can create now the items for this augmented grammar. So given our augmented grammar, let us look at our items. So what is an item? Suppose you have a production of this type, A derives alpha, okay, and if beta and gamma are any two strings of symbols, it may be even the empty string, okay, so beta and gamma are what? Strings of symbols. Strings of symbols, okay, it can be also alpha, can be epsilon also, okay, such that alpha is equal to beta followed by gamma. Okay, so beta followed by gamma. So in that case, an item A derives beta dot gamma is an item. A derives beta dot gamma is an item. So that is what we mean by an item. Let me explain it with an example. So our augmented grammar had S dash derives S. So the items for this particular production would be S dash derives dot S and S dash derives S dot. So for the first one here, our beta is epsilon and gamma is S. Okay, and for our second one here, our beta is S and gamma is epsilon. Okay, so in simple terms, what this means that the first production, what you see here, what it means is that you are scanning. Imagine that you're scanning this right hand side of this production, and you have just started the scanning. So you're in the beginning, you have not seen any symbol, whether it is a terminal or a non-terminal. You have not seen anything. So that is one item. Then in the second item here that you see here, that it means that you have scanned and then you have already seen S and then you are at the end. So this dot marker will indicate what point you have reached in scanning the right hand side of a production. So that is what an item is. So let us take another one. Let us take, say, S derives S. Okay. So here this is another production. So here what would be my items? So I'll start from the beginning. I have not seen anything. Another item would be, I have seen the parenthesis, then comes the dot, and then this part I have not seen. S bracket closing and S I have not seen. Then another item would be, I have seen this too, but I have not seen the rest. Okay. Another item would be, I have seen S dot and then I have S left. And then again another item would be, I have seen everything of this production that is there to be seen. So this is what an item is. So for every production we have to construct the set of all items. Okay. So for the first production that we have here, for the first production, this one, the items are this and this. For the second production, that is this, the set of items is this. Now we have a third production. Let me just write it here. Third production was S derives epsilon. So S derives epsilon means nothing is there. So the item would be just empty dot. There's nothing to see. Okay. So just empty dot. So for each of these productions, now I have a set of items. So this is an item. Let me take another example. This is the grammar and I have augmented it to E derives E plus N or N. So here let us construct the items. So what are the items? So the items here would be from E dash, either I have not seen E or I have seen E. So these two. From the second production, I start at the beginning, E plus N, okay, or I have seen E, I have not seen plus N, I have seen E and plus, but I have not seen N, or I have E plus N and then, and finished. And the last production is E derives N, so either I have not seen anything or I have seen N. So this is the set of all items of this particular augmented grammar. So in the next video, we are going to talk about the two functions of constructing the Lr parsing table. So Lr parsing table. So to get that, we have two processes that we have to follow. One is called closure and the second is called goto. So we have to construct the closure set and we have to construct the goto set of the items. So we'll see that in the next video.